know what's going on, but that means like I can't post the video for anyone that didn't get on live to watch. If I don't hit record, there is no video proof that this happened. So, yep. Now watch, I'm going to try to do my clicker and it's not going to work. Yeah. Okay, that works. I'm back in my screen. Might help if I turned it on. It's not working. Why isn't it working? It's off. Okay, so in 1936, FDR had been president for one term at that point. The magazine, the Literary Digest, predicted ALF Landon would beat FDR in that year's election 57 to 43%. The Digest mailed over 10 million questionnaires to names drawn from a list of automobile and telephone owners. And over 2.3 million people responded. Pretty good sized sample. At the same time, a young man named George Gallup, if you've ever heard of the Gallup poll, yep. He's the one that developed it, sampled only 50,000 people and predicted that Roosevelt would win. Gallup's prediction was ridiculed as naive. After all, the Digest had predicted the winner in every election since 1916 and had based its predictions on the largest response to any poll in history. But Roosevelt won with 62% of the vote. So the size of the error is pretty large here if you consider they said Roosevelt would get 43%. He actually got 62% of the vote.
Almost doubled it.
At least a time and a half. About a time and a half. Yep. So that's a pretty big error. But let's look at these and just to kind of see what could have went wrong. We're going to talk about what went wrong as we go through today. But just to kind of discuss for a second things that could have went wrong. If you look at this poll by the Literary Digest, what are some things you notice about it? What are some things they could have done that maybe that we learned yesterday that's like, I don't know that that's valid? They only used automobile and telephone owners. What happens if you don't have an automobile or telephone?
Can't respond.
Can't respond. They don't have your address.
Well, you won't even hear about it.
Yeah, you won't even know about it. That's right.
That's what I was curious about. It seems kind of impractical, even at that, like since in 36, like it just seems kind of impractical to try to fault people who wouldn't have an automobile or telephone, though, would it?
Well, for their case, I mean, that for them it wouldn't be practical because you couldn't easily access them. You'd have to send people out to their address.
Yeah, that's what I'm saying.
Yeah. But then also, what did we talk about? If people do what, it's not really going to be that accurate. And the key here that I'm getting at is they did it by how? Mail. So if you get a survey, do you have to mail it back? Which means those that do could be considered what? Starts with a V. So, volunteers. They voluntarily mailed their ballots back.
That's not good.
No, yeah, you can't generalize to a population if your study is only based on volunteers. But now the Gallup sample, they didn't really say how he did his sample. They just said, seriously, dude, we've predicted every election since 1916. Which if you think about it again, how many elections had been since, they were in 36. 1916 was how many years before? 20 years. How many election cycles? 5. So like, we predicted the last 5, we're bound to be right. I could understand if they had like predicted I guess it would be 4, because they're in the 5th cycle. Yeah. So I could understand where it's like, oh, well, we predicted the last 20 elections. I don't see how yours is going to be accurate. We know what we're doing. But it was 4 elections. Like, good grief. Get over yourself. So this is a classic example of how bias affects the results of the sample. And we just kind of talked about some reasons. So now let's actually look into bias. So bias is the tendency for samples to differ from the corresponding population in some systematic way. So the first type of bias we're going to look at is called selection bias. So suppose we want to take a sample by randomly selecting names from the phone book. Some groups will not have the opportunity of being selected. Why?
So they don't have a telephone.
They don't have a telephone. That's a good one. What else? What are listed in, or let me back up. Do you have to have your phone number in the phone book?
No.
No. People have unlisted, even if they have a landline, they have unlisted numbers. They can request to not be listed anywhere.
So it's voluntary.
Phone book, you could say it's voluntary, yeah. So let's be careful with bias, because there's actually one that deals with voluntary bias. So let's be careful with that. But people, if you don't want your number in a phone book, you can be added to like a do not call type list, and then they cannot put your number in the book. People without phone numbers. You don't have a well, you probably do, but just go with me here. You don't have a cell phone, you don't have a landline, you don't have some web-based remind type app where you can call or Google Meets. You don't have any of that. If they want to find you, they have to come hunt you down. Or, this is probably the most current issue, people with only cell phones. Some people change their cell phone number like they change their underwear. I can't say I'm one of those. I've had the same phone number since I got a phone my freshman year of high school. In case third period didn't catch this, but just so y'all know, these are what go on those 3 dots. In case you didn't catch it either. Yeah. Okay. So selection bias occurs when the way the sample is selected systematically excludes some part of the population of interest. And we call that undercoverage. So if you just pick people out of a phone book, we just saw you're leaving people out. So that would result in undercoverage. Now, in this case, it may also occur if only volunteers or self-selected individuals are used in the study. So like those mail-in surveys that we talked about for FDR. I mean, you kind of self-select. You either look at it and you're like, I'm going to respond to this, or you look at it and throw it in the fire, burn it. Probably. And those times you either threw it away or you probably burned it. So, bless you. Suppose that we decided to survey only the students in our class. Why might this cause bias in a survey?
Because some people don't take statistics.
Some people don't take statistics. Yeah. And then let's think about the grade levels in here. Let's say we're doing that cell phone survey like we did yesterday. So we're mostly juniors and seniors. Or we're all juniors and seniors. What about sophomores and freshmen? Would we give any of those opinions if we just surveyed this class? Nope. No freshman or sophomore opinion. So this is considered convenience sampling. If this was the only sample, that would be because of convenience. I didn't have to go to the floor. I just print them out, pass them out, and that's that. So it's using an easily available or convenient group to form a sample. So this is often done if you've ever, I don't know, unless you're like on the AC campus, you know, like at some student organization or something, doing a study. I know at A&M, I saw several, they would just like get outside the building and, hey, can you answer a couple of questions for me? As people came out of the building. That's convenient. They just catch you as you walk out of the building. So the group may not be representative of the population of interest. I mean, like, if I'm coming out of our building at A&M that's business, or the building itself is called Wayner, come out of Wayner and there's someone standing there doing a survey, chances are they're just grabbing business majors. Because that's all that's coming out of that building pretty much. The results should not be generalized to the population. And they can also occur when the sample relies entirely on volunteers to be part of the sample. And that's called voluntary response. So convenience sampling is a type of selection bias. Convenience sampling is a type of selection bias. So an example would be the surveys in magazines that ask readers to mail in their survey. Or they could be like the call-in shows. If you watched American Idol and they get down to the finals and they perform, or if, I don't know, if Oswald is your favorite singer, text vote 10 to 1-800-999-IDOL to vote, or log on to vote, or whatever. That's American Idol. Let's see, what other shows do stuff like that? The Voice. America's Got Talent. Those kinds of shows are all convenient sampling. The respondent selects themselves to participate in the survey. So now let's look at measurement or response bias.
Mr. Joel, what did you say the respondent was again?
Which one?
Harvey got one.
Oh, that one.
Oh, my bad, I didn't see
The
that.
respondent selects themselves.
Gotcha. I was looking at the book. Thank you.
Okay, so measurement or response bias occurs when the method of observation tends to produce values that systematically differ from the true value in some way. So if you've taken like chemistry or physics or biology and they ask you to weigh something on a balance, what's one of the first things they usually tell you? Or even just a normal scale. Make sure you tare your scale. Or they may say, make sure you balance your scale. Tare is the technical word, but balance. Make sure you balance your scale before you weigh. If you didn't, everything you weighed would be wrong after that. So, improperly calibrated scale used to weigh items. That's one example. So, balance your scale before you do the experiment or whatever. Another one is the tendency of people to not be completely honest when asked about illegal behavior or unpopular beliefs. I mean, hopefully it hasn't happened to y'all. Even if it did, y'all probably wouldn't say. Thus, response bias. But you're sitting there, you're driving 70 down Timberland. LPD pulls you over. You know why I pulled you over today? Oh, no, officer, I don't know. I'm sorry. Well, speed limit's 45 through here, and you're driving 70. Oh, I'm sorry, I didn't realize that. As you pass everybody. I mean, or another example. Suppose we went around and asked students about drug abuse and a uniformed police officer interviewed you. Do you abuse drugs? No, sir. No, not at all. I mean, if it was a uniformed police officer, would you sit there? Oh, yes, sir. Here, you want to see my backpack? No.
Be truthful.
You should be truthful.
Obey the law.
Exactly. You would not get honest answers.
Of course, when an honest person would take risks anyway.
Yeah.
Just ask him if he wants some.
Appearance or behavior of the person is another way you could get response bias. So, if a guy with a mustache asks you if you trust men with mustaches, well, I don't know. Should I trust you? That's probably what I'll look at him and say, I don't know. Why are you asking me this? Are you trying to say I shouldn't trust you? And then questions on a survey are worded in a way that tend to influence the response. This is where some of them tend to get you. So you're doing a survey, seems innocent enough, think they're asking your honest opinion, but then they word it, did you have a good experience with our customer service team today? What word did they just put in your head? Good. Instead, they may want to say something like, how was your experience with customer service? If you would.
You just answer no by default.
Yeah. So one example that was published, one example of a survey published in the Wall Street Journal in 1994 included the following question. It's estimated that disposable diapers account for less than 2% of trash in today's landfills. In contrast, beverage containers, third-class mail, and yard waste are estimated to account for 21% of trash. Given this information, in your opinion, would it be fair to tax or ban disposable diapers? So what do y'all think most people would probably say to that question?
No.
Yeah, they're going to look at it. It's only 2%. I mean, my gosh. We have a 21% right here. So why are we taxing 2% of our stuff that fills the landfill? The way they worded that question in itself was biased. So now let's move on to something called non-response bias. So kind of picture this. The phone rings, you answer. Hello? The other person says, do you have time for a survey about radio stations? And then next thing you know, click. You hang up. That's non-response bias. They may have done everything valid up until that point. They randomly selected you. Somehow they got your number, but you were randomly selected. They called you, and then you hung up on them. So therefore, they did not obtain your response. Responses are not obtained from all individuals selected for inclusion in the sample. To minimize this bias, it's critical that you make a serious effort to follow up with those who did not respond to your initial request. So, in that example, how much you do a follow-up? Call them again? What would you say? Please don't hang up. I really need you to do this survey. Yeah, you can do something like that. Maybe call and say, I apologize. We're doing this survey for XYZ. Could you please give us a minute or two of your time? I promise to keep it short. So People are chosen by the researchers, but refuse to participate. For non-response bias, they're chosen, but they refuse to participate. They are not self-selected. Maybe you want to write that by, if it's not already there, write that by non-response bias. They are chosen, but they refuse to participate. So we can't say this is voluntary. People often confuse those two. Oh, well, those that participate, they're voluntary. No. The ones chosen refused to participate.
So you said if they're not self-selected, that means that they can't be volunteers?
Yeah, if they're not self-selected, then, I mean, the whole deal with self-selection is you select yourself to participate. So if they're not self-selected, then you can't say they're volunteers. They just simply refuse. So one important note on bias is that bias is introduced by the way in which a sample is selected, so that increasing the size of the sample does nothing to reduce the bias. You can say, oh, I want to sample 500. 20 of them hang up on you. You call, they hang up. Okay, fine. I didn't get those 20, so I'll call 20 extra. How many did you now attempt to call?
40.
Well, I'm talking about, so you do all 500, you see 20 didn't respond, so you called 20 more.
I thought you said like there were only 20. My bad. I thought it was about 20.
Yeah, now you're up to 520.
My bad. I misheard.
That's okay. So it's not that, oh yes, I got my 500, I'll just throw out the other 20 that didn't respond. No, it doesn't work like that. So we're gonna, just to try to break the monotony up, do a small activity like we did last week. There's 3 of these examples. I'm gonna group y'all in like rows of 2 and get assigned basically a problem for y'all to talk about. So AP, I want y'all to do number 2. The 2 rows closest to the door, y'all talk about number 1. And these 2 rows talk about number 3. So you can turn to your neighbor, talk about what's a potential source of bias. Yeah, I know there are 2. I think y'all are 1. Y'all are 3. So the 2 closest to me are 3. Y'all are 1. AP is 2.
I heard it.
No.
At 3 o'clock?
I can look outside and see if it's raining.
It is.
Oh, bro. Put us in the indoor.
I was there.
I can tell just when you hear that on the radio, you just hear that. That's rain.
It's also.
That's rain up here.
I used to always think that, and then like I go down and it's sunny, it's like, I look, and then one day I realized that they roll the car, because I always thought it was raining every day, and like, outside of the place, just roll the car down.
Yeah.
Hallway, and I
That actually is rain.
dude, hallway.
Yeah, or classroom.
No? No, you're not hallway. All of your hallway, what are you, no. You get the indoor. Okay, I kinda want to do hallway.
I kind of want to go.
Also, we can send over the indoor if you want. Humidity.
Okay. Y'all still want a minute or two, or y'all think y'all are ready?
We're good.
Brother, you're not even saying selling people. Please don't roll it. I don't.
Yeah, I'm bad at kind of slack it off.
Oh, yeah, we got it. 70% of people maybe 40.
Oh, please tell me don't cancel, I just go.
Play golf?
That's what I go after this.
I'll go play golf.
Yes, sir. It rained, go home.
Really?
Don't play golf in the rain?
Or if it's
I
too
was
cold.
trying to take a picture of the bird.
Yeah, it's like 30 something outside, we'll go home.
That sounds like awesome weather.
No, I do not like the cold. Awesome weather is like 75, 80.
No.
I'm thinking going 105 degrees. It was 105 degrees and it had like a 60% humidity.
Okay, group one. What'd y'all think for this one?
Selection bias.
So,
Oh, we're supposed to prove this time.
it is selection bias. Why did y'all say selection bias?
Because only
I thought it said find the bias.
description of car owners and co-owners.
That's right.
Yes, sir.
Selection bias, since the digest survey came from car owners, etc. The people selected, being that they owned vehicles, had a phone, they subscribed to magazines, were probably from the higher income families. If you had a low income, you didn't have money to just throw out on a magazine subscription every year and buy a car and they're saying the Republican part, I don't really know if I would say, unless there was proof that this literary digest was primarily like Republican leaning.
There's been something about politics in every one of my classes today.
Okay, number two.
We said non-response bias, because a lot of people don't like to give their receipts and stuff, they just spread it over away.
I could see that.
Some people are kind of paranoid about this.
Yeah,
And we also said that it could be convenience sampling.
it is definitely convenience sampling. And convenience sampling is a type of what?
Selection bias.
Selection bias. There you go. Because they just stood at the entrance, or the exit, I should say, and then during lunch, got the receipts. But also, it's selection bias, because what if you bought books online? Is there any chance you could be included in those results? No, you bought them online. So students who buy their books from online bookstores were excluded. And just a real life tip, like not related to this class, but just real life tip, do not, unless that's the only place, do not buy from the campus bookstore.
Like in any college, or just A&M?
Any college. You can usually find them cheaper on Amazon, or there's a website called cheapesttextbooks.com that searches all websites and gives you like a rundown of who has the cheapest price for the book. You can also what? I'm not going there. Yes.
So, like, I wonder how much people spend a year on, textbooks for college.
It depends on your classes, honestly. Math textbooks, or I can speak from experience being a math major, are really expensive.
Like, 1,000? 100?
You could probably spend easy, if you're in 5 math classes, you could probably spend easily $700 to $800 on textbooks if you buy them all brand new.
Sounds fine to go.
People,
Yeah. One math textbook new, because most colleges use the newest edition. Most math textbooks run about $150 for a book.
That's honestly way better than I thought it was. I thought it was gonna be.
I've had a couple of books that were north of $200. You use it for 4 months and then you're done with it.
Never touched it again.
And you never touch it again. Yeah, so very rarely did I buy a new book, and very rarely did I buy books from the campus bookstore. No. Too expensive. Okay, group 3.
We said that it was selection bias because because not everybody has to like sell their house like a realtor, like that.
No, that's exactly right. Selection bias. Yet not only does not everyone have to sell with a realtor, but not everyone has to be selling their house. So homes that are not for sale or homes that are listed with different realtors, that's not going to work. So selection bias, definitely. Okay, good analysis. So now let's look at section 2.3, simple comparative experiments. So a simple comparative experiment is an experiment with a planned intervention undertaken to observe the effects of one or more explanatory variables, often called factors, on a response variable. So the design of the experiment is the overall plan for conducting the experiment. So before any study is done, they have to design it. You can't just start going out and asking people questions. It's got to be well thought out, well designed, so that way you minimize any ambiguity in the results. Well, it could be this because of X, Y, and Z, or it could be that. You don't want that ambiguity. So an experiment that's deliberate imposes some treatment on individuals in order to observe their response. So we had a good discussion yesterday about the 3-hour versus 6-hour chemistry lab. That was the treatment. Did you get a 3-hour lab or a 6-hour lab? It allows the measurement of effect of a treatment. And it can help control confounding variables and give good evidence of causation. The deal with an experiment is you want to try to control every single thing except your treatments. That way it rules any other effect out. So today's main example is going to be a calculus class, calculus exam. Suppose we're interested in determining the effect of room temperature on the performance on a first semester calculus exam. So we just do an experiment. What variable will we measure? The performance. We're going to actually measure their performance on the test. This is called the response variable. It's a variable that is not controlled by the experimenter and that is measured as a part of the experiment. So that's why it can't be temperature. Temperature is going to be controlled. We're controlling that. Which answers our next question. Which variable will explain the results on the calculus exam? The temperature. The room temperature. This is called the explanatory variable. And there are those variables that have values that are controlled by the experimenter, which are also called factors. So now, let's keep going. Wait, was there a blank there? No blank. Let's keep going with this example. So let's say we decide to use two temperature settings. One group is going to be testing in 65 degrees, the other group in 75 degrees. How many treatments would our experiment have? Two? Which two? Perfect. That's it. So experimental conditions, any particular combination of the explanatory variables or treatments. So there's two treatments, and those two are our temperature settings. So if you want to write that beside that question, how many treatments? 2. So suppose that we have 10 sections of first semester calculus that have agreed to participate. On who or what will we impose the treatments?
What will we do with the treatments? Like, what will we give them to?
Yeah, who will we give them to?
The students second.
Yep, but let's be a little bit more specific this time. The students where? In the 10 sections of first semester calculus, yes. The 10 sections of calculus.
What does it mean by 10 sections?
So a section is like a class, basically.
Okay, I got you.
So since I teach 2 periods of statistics, I could say I teach 2 sections of statistics. Uh-huh. These are our subjects or experimental units. So each section is a subject or what you'd call an experimental unit. And they're the smallest unit to which a treatment is applied. Now you may be asking, well, why aren't the students themselves a unit? Let's think about that. Could I walk through this room and say, Riley, you're taking the test at 65 degrees. Kyron, you're 65. Justine, you're going to be 65. Steven, you're 75. Could I just keep just going through like that? And then have y'all all take the test in this room at the same time? No, the room's going to be one temperature. So we can't do it individually unless you actually split y'all up and put y'all in two different rooms. Therefore, we got to say the whole class is one unit. Does that make sense? So how do we determine which sections are going to test at 65 and which test at 75? Well, that panel. Yes, but how do we determine who goes where?
I got a random.
Random, yes. We need to randomly assign the treatments. The thing with an experiment, if you can't control it, you gotta be random. You either have to control it directly or be random for it to be fair. So random assignment of subjects to treatments or treatments to trials ensures that the experiment does not systematically favor one treatment over the other. Is that a blank? No. Okay, so let's start assigning them. To randomly assign the 10 sections of first semester calculus to the two treatment groups, we would first number the classes 1 to 10. Well, we put the numbers 1 to 10 on identical slips of paper. There's that identical coming up again. And then we put them all into a hat and shake it up really good. And then we start drawing. And that's when I thought about, like, I want to do it to where we actually draw, but then I realized it's already animated in the slideshow. So we're going to randomly select 5 numbers from the hat. And those will be the selections that have the room temperature set at 65 degrees. I feel sorry for the ones that get drawn first. So section 9 gets 65 degrees. Seven, 65 degrees. Whoa. What? Thank you. 5, 65 degrees. 8 gets 65 degrees. And the last one, 3. I felt like there was a pattern there, and that kind of bothers me, but supposedly it was all random. So then everyone else gets 75 degrees. 1, 2, 4, 6, and 10 get thrown into the 75 degree ring. So, go ahead. So say, notice that there's 5 sections assigned to each treatment. We didn't do 8 rooms at 65, 2 rooms at 75. As Riley mentioned, we need to split them in half and do 5 and 5. And we did that randomly. This is called replication. Replication ensures that we have an adequate number of observations in each treatment. It would not be fair if more were in one treatment than the other. So, why is replication an important trait of a well-designed experiment? Why is it important?
To confirm the results.
To confirm the results, yeah. That's one. The main reason it's important is it helps to neutralize any possible variables you can't control. Like I said earlier, if you can't control it directly, randomize it. Scatter it out everywhere. So replication helps to control just the natural variation in the classes. I mean, one class may have people who love calculus, they're good at it. The next class, everyone hates calculus. Why do I have to be up at 8 a.m. doing calculus? They get to come at 10. So, remember that the explanatory variable is the room temperature settings, 65 and 75. That's what we're changing. Our response is the grade on the calculus exam. So, those two we know. What are some other variables that could affect our response? How what? That's definitely one. Student ability. That's one. Oh, I just gave y'all a hint on one. I can't remember which order these are. Time of day, good. Time of day, perfect. That's another one. What about another possible variable? No, they're all taking the same test. All taking the same test. Instructor. Can I be, if calculus is all at 10 a.m., can one instructor be in all 10 sections at the same time? No. We're not going to say, yeah. Put Zoom on the screen on the other 9. No, we're not going there. Can they physically be standing in 10 different classes? No. Textbook. That could be another. And then the last one we already said. Ability level of the students. Some could be really good, some not so good. These variables are called extraneous variables. They're a variable that's not one of the explanatory ones. They're not a treatment. But it could affect the response. So in a well-designed experiment, you need to try to figure out how to control all of these. Now you may be thinking, how can you control their ability level? Like, you can't go up to someone, Mr. Schultz, and say, you will be good in calculus. Or else. So in an experiment, these variables need to be controlled. Now, one type of control that we can use is called direct control. That's where we hold them constant so their effects are not confounded with those of the experimental conditions. Remember, confounded means that it almost invalidates the result. So can the experimenter control these extraneous variables? If so, how? Well, let's see. Let's go back. Let's go back there. Okay, so is there one of these four variables that we listed that the experimenter could control? Time of day. Yep. It'd be really hard, but you could control that. You could say everyone takes calculus at 10 o'clock in the morning. Or everyone takes their test at 10 o'clock in the morning. And, wait, why would I say that's really hard? That's actually common. At least at A&M, that was common. If you were in Calculus 1, which A&M called Calculus 171, or not Calculus, Math 171, they would have a common exam. It would not be during your class. You would have to come that night, probably around 6 or 7, take your exam, all calculus students all at once, and then go. And there's two reasons, main reasons they do it. One, you can't talk to other students because everyone's testing at the same time. You can't go to your friend, hey, what was that calculus exam? What should I study? I have it in 10 minutes. What should I study? Can't do it because they're testing the same time you're testing. Two, they can actually evaluate, for one, the curriculum, and two, the professors. That's one, evaluate the professors. So that's actually kind of common for exams. Okay, so we figured out how to control time of day. What's something else that we could control pretty easily? Textbook. Everyone gets the same calculus textbook. That is common. That's pretty common. I mean, you go to them and they're like, I really like to use this textbook. Well, you can use it next year when we vote on it again. We voted on this one. Everyone's using this one. End of story. So that one's pretty common. But now there's still two. There's still the instructor and the ability level that we haven't done anything with. We've controlled time of day. We've controlled textbook. But we haven't done instructor or ability. So remember, two variables are confounding if their effects on the response cannot be distinguished from each other. This purple box is something that you need to fill in the blank for. I didn't catch it last period, and half of them didn't catch it until I'm like, click, click. Oh, wait. So make sure you catch that. We're almost done. We're going to go down to where it says 2.4, and then we're going to stop. So we're almost done. Okay, so suppose that there's 5 instructors who teach first semester calculus. We do not have direct control of this variable. However, we could have each instructor teach 2 sections. So each one gets 2 sections, and then we randomly assign which one of the 2 sections get the 65-degree temperature and which one gets the 75. This is an example of blocking. So blocking is a process by which an extraneous variable's effects are filtered out. Similar groups, blocks, are created, and all treatments are tried in each block. So if I was one of the professors, one of my classes would be doing it at 65, the other at 75. And chances are, I probably wouldn't even know which is which until I walked in the room. But what about the extraneous variables we cannot control directly and we can't block? So which one's left? We talked about books, time of day, and instructor. Ability. Like we said, we can't force them to all be good in calculus or force them to all be bad at calculus. So then we use random assignment to evenly spread all extraneous variables that are not controlled directly or that are not blocked into all treatment groups. So what this would look like in this experiment is the student couldn't pick their professor. They would be randomly assigned to their class, and that's how it'd have to stay. So when we evenly spread them out through random assignment, we expect the variables to be affected in the same way. Just sprinkle them around like confetti. Okay, so that's kind of the basics of experimental design. We'll do section 2.4 tomorrow, where we get even deeper into design. Yes. Go back, sure. Just sign out. This may be a good time to work on the assignment for whichever. If you're dual credit, pull out your assignment and see what we've covered that you could answer. Because you can ask me and it not cost a try on Blackboard.
And this one we also have 3 attempts, right?
Yeah, every homework assignment dual credit has 3 attempts. I was about to say 3 attempts. Yeah, 3 attempts.
Thank you, Mr. Schultz.
You're welcome.
What questions did you do with all people's reactions?
So if y'all want to change anything on that first assignment that deals with convenience sampling, you can change it and turn it back in. Okay, use of direct control. Yusuf, is there? Do you remember about what it's? I know you said direct.